Hey, how's it going? So I'm going to take about 5 minutes or so to show you guys two Phets or interactive simulations that you can use to better understand reactions and reaction kinetics. So the first one that we're going to use is reversible reactions. So if you go Google Phet reversible reactions, here's our title. You will come up with this app, and if you just need to download it to be able to use it. So I've already downloaded one. So here it is. Just going to go to full screen. All right. So what can you do with this app? Well, you can look at the molecules and the reactions. So I'm just going to put like 10 of them here. So these represent the reactant side of the equation. I'm going to raise the activation energy to an extremely high amount. Okay, what are the odds of these molecules being able to have enough activation energy to get over that barrier and then fall down the energy hill to become products? So I could wait for 5 minutes or 10 minutes, and then maybe randomly one of them, like that one, oh my gosh, right on cue. So now we have one product. If we look over here, I've got 10 reactants and one product. Now, what are the odds of that product having enough energy to come back as a reactant? It's possible. This is a reversible reaction. That's what these arrows are showing us. If I lower the activation energy, I increase the chances of the reaction moving forward and reverse, as you just saw. I could also raise this. And now, by the way, this was endo or exothermic right here. Okay, what if I raise this? Now is it endo or exothermic? Maybe I'll lower this one. Okay, so this would be an endothermic reaction. We have one product. Who's more stable, reactants or products? Which way are the molecules likely to go when this thing sits over time and reaches its sort of equilibrium or final position? More reactants or more products? Okay, so this one's pretty simple. There's not a lot to do here. We're going to move to the second simulation, which has a lot more features going on. If I can just move this out of the way to find it. Oh, here we go. Okay, so this one has lots going on. First of all, I'm going to show you just a straightforward reaction. I'm going to add the energy diagram. And you can see that this one is endo or exothermic, looking at the energy diagram. Here's our reactants, and here's our products. So you would say it is endothermic. So who's going to have more energy, my reactants or my products? Products will. How are they going to get energy? I'm going to have to add them by pulling back on this plunger. And you can see the energy bar on the graph is going up, 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 up. So I'm pulling back. If I pull back this far, do I have enough energy to break bonds? And the answer is no. I have not climbed the activation hill and added enough activation energy. So we'll try it again, reset or reload the launcher. So this time when I pull it back, I have to have enough total energy to break bonds, which I think I've now done. And there we go. So now we have products, reactants, more energy, less energy. Okay. The other thing you can do with this is change the angle. So this time I am going to, where's my setting? Angled shot right here, sorry. So now I can change the angle of orientation for the collision. So this time I'm going to pull it back and add enough energy to break the bonds. Okay, why didn't we have a successful collision to create two new products? Because we had enough speed or kinetic energy. And the answer would be, we didn't have the correct orientation. You're welcome to watch this run for 5 minutes on your own to see if you can eventually get it to collide at the correct orientation with enough kinetic energy to break bonds and make bonds. Now, you've got different reactions. I could choose reaction 2 or 3 or 4. So this one is very exothermic with literally no activation energy. Anything at all that I give this is going to be enough energy to create a product. Break a bond and make a bond. Okay, so we're now in a very stable position for our product sitting down here. The chances of it going up this energy hill in reverse and becoming reactant are very slim. So there's lots of variables to manipulate on this side, and then you can go to many collisions and play around with this one. Again, it's all the same sort of variables. We can raise or lower the temperature. We can choose 5 different reactions. Oh, here's a very exothermic. You can choose how many of A you want to put in, how many of B and C you want to put in. Start over. I'm going to try some A, B, some product, and C, and just manipulate it. Change the variable, see what's happening, and see if you can figure out how these different variables affect reaction rate. Okay, enjoy.